Hello guys, welcome back to my Around Weapon FA tutorial. And according to the previous one, I have already cached all of the 4 files. And let's move on to the loop depth, lighting, rendering, and compositing part. So let's get outside and create a camera for rendering. Camera. Okay, so I think it should be easier if we can have the same settings. So we can have the same result in this tutorial. So for the translation, I will set it to 2.8. On the YC it should be 0.9, and the Z-axis would be 2.63, and for the rotation I only set the YC to minus 45.4, and let's preview this. And by default we can have a rendering like this, but to make it more interesting we can have a node to control our camera animation. Let's create a node and plug it right here, and maybe we can scale it a bit, yeah, to 1.15, and reduce the translation to 0.2 minus 0.2, and to control the animation we can key the y-axis on the rotation. And so let's move on to the first frame, and in this case it's 101, and let's have a key on this frame, and when it reaches to the frame 172 let's key it to 35. So right away we can see our animation here. So let's play this, and we can furthermore control our animation by shift click on this value and get inside. We can change this curve to a straight curve. Okay, so let's get outside. So this is our camera animation. Okay, so let's create a two specific containers for our particle shield and particle sort, and let's create a geometry. I will name this to RNDR, maybe shield, and let's create an object merge, and let's get the node in the setup. This right here, our shield BRT, and Control V here. Control C and Control V here. Okay, so this is our shield particle, and let's do the same for the sort. And let's on click on this, turn off this, and get inside, and we need to copy our sort particle. Control C, Control V here. Okay, so we have our sort and shield particle. So let's preview this on the frame 1024. Maybe the sort is not attached to the animation, so let's check it out. Oh, I take the wrong one. So let's change this to the import. Okay, so let's see. Let's take our sort. So this is the sort that has animation, and this is a static version. So let's Control C this and go to the setup, and this should be our source static version. And for this, and this should be our short animation. So right away it should be fine. Okay, so the shot will be relocated to the correct position. Okay, so let's create a material for our particle. So let's create a magnet material network, get inside and create a mancha material builder, and we can name this to particle material or particle mat. Get inside, and for the particle material is really simple. We just need to buy our CD. We need to take our CD from our particle, and the CD should be the vector type, and we can name this, sorry, the CD, name this to CD, and we plug the CD to the color, to the surface color, and yeah, it's pretty much done. And we can copy the material builder, sorry, the particle mat to these containers. And for sure we need motion blur on this, so let's set the sampling to velocity blur. Okay, so let's make these two containers to be red by clicking on the C on the keyboard and make it red so it can be stand out from the others. And obviously we can change this to INDR sort. Okay, so let's create a mancha node for rendering, and mancha, we can name this to cell particle version 1. Okay, so by default it should be, so let's set all of this to reverse to default, so we can make so we can set this all again from scratch. And the frame range should be random frame range, and we can delete this start channel, delete channels, and set it to 101 since we only need to render from the frame 101 to 172. The camera should be fine. We create a camera 1 here, and the output picture, we can make a specific folder for this. Those side job render, those side OS, and as I mentioned before, $OS is a we'll take the name of our mantra and paste this to here, and slash $OS dot $sign F4. And since we in our render, for example 101 contains 4 digits, so we need to have a 4 here. And finally we need EXR, which is our universal file format for VFX. Okay, so let's get to the rendering tab, and the ray tracing should be fine, and we definitely need our allow motion blur. And the shutter offset, I usually set it to -1, because we need our particle to be trailed back, which is more physically accurate. And the object should be first object. We only need to render the shield, and we don't need any light here. Turn off the headlight creation, and I think it should be fine. Let's save the scene and toggle to the render view, and we can have our first render. So let's move on to the frame 150. Let's wait a bit. Okay, so click on render. Okay, so this is our seal particle, and obviously we need a lot of work to make it, look nicer. And first thing first, we need a mat for our for rendering. So let's create a container for that, and let's create a geo and name this as mat, and let's get inside the import, and we take the out character, Ctrl C, dive inside the mat, maybe change the background to dark again, and let's create an object merge and Ctrl V to this tab. Okay, so this is our mat, and let's okay, so let's get to the matcha node, and for the object tab we need you can see the first mat here, and navigate to the mat container, click on accept, and let's save this as the snap one and render to see the difference. Okay, so this is the render with our mat. We can see some particle are deleted here. Secondly, we can obviously see that the particles here is way too messy right now, and we might need to delete some particles that are way outside, sorry, that are way far away from this shield. And to do that, I might need to demonstrate this in Paint application, and I'm gonna draw a sword. And excuse me for my bad drawing, I'm not really a painter. Okay, so for example, this is our sword, and there are some particles that are swirl around the sword. Okay, so all we really care about is the particle in this area, and we need to delete the particles that are outside this area. And to do that, we need to identify the p scale, and the p scale. Okay, so we want the particles that are inside this bounding box to be 1, and the particles that are in other areas to be 0, so we can have a range from 0 to 1. And so we have to, all we have to do is just to calculate the distance from this part. So for example, this particle to this sword, so for example, this distance is 0.7. Okay, so now let's hop right into Houdini and do this, and we need to write some lines of code to calculate the distance, a rectangle. Okay, so first thing first, let's calculate the distance. We identify the distance by a float, and we can use the XYZ Dist expression, and you can press F1 to open the documentation to really understand the meaning behind this. So we need a geometry for this and a vector, and for the geometry we need our shield as the destination to calculate the distance. So let's plug the static shield to the second input, and the second input in attribute rectangle should be 1, and the first input is 0, and the second input is 1. Okay, so the vector we need here is p, is the position of our particles. Okay, So right now we can calculate the distance from each particle to our shield, and from that we can fit the distance to be the range from uh, the range from 1 to the range from 0 to 1, and the material we need here is this, and we need to fit that from 0 to the max distance. That we need to create a channel here, and fit it from 1 to 0. Okay, and we might need to create a RAM for this, and I will explain this later. CH we can name this disk RAM and disk. Okay, so all we have right now is a RAM from 0 to 1, so we can multiply the particles here. So for example, all the particles right now have a constant value of of 0.5. So if the particles that are inside this bounding box, it will be multiplied as 1, so it will stay the same as 0.5. But if they are outside the bounding box, which is right here, they will be multiplied this to 0, which is 0. Okay, so 0 p scale equal to 0, meaning that we don't have any particle. Okay, so hope that makes sense. So let's multiply the speed scale by the distance. Okay, and we need to expose all the parameters here. Okay, so for the disk RAM, I think the disk RAM is just for create a smooth transition from this particle outside to the inside, so we can create a very smooth curve here by change the interpolation to Bezier. Okay, and the reason why we need to fit this, because for example, this particle are way, so this particle here are way to outside, so they might have the value above 1, maybe they are 1.2 for example. So we need to fit all of this to the range of 0 to 1, so it's much easier to calculate. Okay, so let's use this mark distance as 1.2, and for the disk RAM, maybe I will alter this a bit to make it smoother. Okay, so let's have our second render. Okay, so this is a result from using this attribute wrangle, and as you can see, some particles that are outside the bounding box are getting deleted, as you can see. Okay, so the problem right here is that the overall speed scale is way too large now, so I might need to reduce this significantly, and we'll add 1 0 and 15, and let's render this again. And yeah, right away we can see the particles have more details now, but the problem is that the images are way too blurry, so we need to increase the pixel sample. So let's save a version of it and increase the pixel sample to 8 by 8. Render this again. Okay, so right away you can see the mesh reduce a lot of noise here, which is looks more nicer. Okay, so all we have to do right now is to copy the same mantra to the and name this to the sort particle v1, and for the objects we change this to indr sort. Okay, so let's copy this triangle to the sort setup and Ctrl V here and remove all the connection by pressing Y and plug this triangle between the P scale and the point deform. And one thing I haven't told you before is that in the previous video I accidentally simulate the particle simulation on the whole sort, which is not really what we want. We only need the particle to be simulated on the upper part, and to solve this we need to come to the source and delete the lower part, and I'm gonna use the bounding selection to choose only the lower part. Okay, so let's hit enter to delete this. So we leave only the upper part and connect this to the remesh, and for this one I think I need a node here, and I'm gonna name this to upper part, upper part. Okay, and I will copy this plus node here and copy and paste this to the particle simulation. And for this fetch I think I might need to cast these two nodes again, and I'm gonna come back when it finishes catching. Change the order to node by node and render. Okay, so I have just finished the catching, and I might need to copy this node here as a new object merge. So let's create a new one and paste this here. And this is the sort with only the upper part, and this is the sort with the full part. And we for this triangle we only need the upper part, so let's just connect this to the second input. Okay, so let's have a look at the render. Okay, so this is our sort render, and I forget to alter the p scale, so let's alter this to the same value that we altered for the shield. Okay, so the max value here might not work for the sort, so I think we need to change the max value a bit. And just so you know, the smaller the max value is, the more particles are getting deleted. So I think I will change this to 0.2, and let's see the result. Save this. Okay, let's change this to 0.75. Okay, much better. As you can see, it's a huge difference. Okay, so I think it's pretty much done for the sort and the shield, and obviously you can change the parameter here to whatever you want. And let's move on to create the ground and the material for our mat. So let's make a material for our character. So let's create a material builder, and we're gonna name this to mat, and dive inside. And for this I need a principal shader, and for this shader you need to plug the surface right into the shader here. And for this base color, I think I will reduce this to 0.1, and the roughness I increase this to bit 2.633, and it should be full metallic and with no reflectivity. Okay, so let's copy the cattle mark to the mat here, to the material of this container, and let's create a ground. So create another geometry node, and I'm going to name this to ground, and let's create a grid. Okay, so let's preview the camera. So the size would be 20, and it should be 16.2. Okay, and later on I'm gonna apply a texture for this grid. So I might need an UV for this one. So I am gonna use the UV quick set. And for the texture map, I'm gonna use my own. Unfortunately, I can provide this to you because it's a paid texture. But you guys can use whatever texture that you have. It's really arbitrary. And I'm gonna use the diffuse one, which is the color. Click on accept. Okay, so it's already have an UV attribute here. And for this one I need to transform it a bit so it is cover on the ground. We have a section which is not filled here, so we might need to rotate it a bit. So for the rotation I will rotate it to maybe 79, so it cover on the ground. And the translation should be -3 on the z-axis. So let's preview this with our character. Let's disable the node. Okay, so this is our full render. And let's create a node here. We can name this to our ground. Since we already assign a material for our ground, we don't need to create any material for it. Okay, so let's create a light for it, environment light, and for this one I only use one light to light up the whole scene. But you know, obviously you can use the three lights, the rim, the key light, and the backlight. It's really up to you, but this is mainly for our effect, so I don't use complex lights like that. So for the environment map, I'm gonna use the HDRI that I have. So I use a decursor. You can download this on the HDRI Haven. It's totally free. Click on accept, and this is our environment light. And we can disable light in the viewport. Okay, so let's render this. Let's create a new mancha node, and for this one I'm gonna name this to char, and object, first object I'm gonna use the math container, and the candidate line is only the environment line, so it should be fine. Okay, so we don't need much blur on this because this movement of this character is really slow, so we don't notice any much blur on this. So let's preview this. Okay, so this is our render so far. So as you can see, the source is very dim, so we can lit up by increase the light exposure to 2.5. Let's see. Oh, it's much nicer now. And for the ground, I'm gonna use the same mancha node. Let's on click this and change this to ground. And for the objects, it should be the ground. Okay, so let's render this to see how it looks. Okay, so you can see right now the tiling is really big right now, so we might need to alter this a bit by diving into the ground, the texture scale. Maybe I'm gonna copy parameter and paste relative references to the y and the z axis, and increase the texture scale to 5. And let's see, let's make a snap for this and render. Okay, so as you can see, the tiling is much smaller now. Thinking ahead a little bit, we want the particles to cast light on the character, so it will look more cooler and physically accurate. As you can see in the demo video that I created, the shield and the sword, the particles cast light on the character. So all we have to do right now is to create light mesh, and let's dive inside the setup. And the theory of creating light mesh is that we need to take the particles and convert them to a real mesh by using the VDB techniques. So let's see. So right from the polyform, I'm gonna create a rectangle, and I'm gonna name this to filter. And all we have to do right now is randomly delete the particles to have a lower count, so the VDB will be generated much quicker. And we're gonna use the if expression for this. This is a code that randomly delete the particle based on their ID. If rand ID smaller than a character threshold, a channel that we gonna create it, and it's gonna be deleted by using the remove boy function ptnum. Okay, so let's expose this, and we only need 1% of this particle, so let's type O.99 and hit enter, and as you can see, it will remain only 45,000 particles according to 4 million before. Okay, so let's identify a p scale for this, because I know that we already set a p scale here, but this p scale is just for rendering, and for generate a mesh, it needs a larger p scale. So I'm gonna identify this p scale by using a channel p scale, and the bit scale should be 0.005. And to convert them to a VDB, let's use VDB from particle. Okay, so I think for the voxel size and the medium radius in voxel size, I gonna copy parameter and paste this relative references. And for this case, I use the same bit scale, the same value for the bit scale, and let's see. Okay, and right now you can see the VDB is really messy, so let's smooth this by using the VDB smooth. Okay, so the iteration is way too large, so let's reduce this to only one. So we have our VDB, and let's convert this to a real mesh. Use convert VDB and convert this to polygons. So this is our light mesh. Okay, so let's copy this object merge node and paste it right here, and let's select all of them to create a merge node. And we are having a problem, and the problem is that some parts of the light mesh are too near to the shield, which will create some overglow part on the shield, which not really ideal. So to solve this, there are two ways. The first one would be to delete all of these parts that are near to the shield, and the second one would be we can push the mesh further away from the shield using the pick node. And to use the pick node, we need to generate normal. So let's do that. Let's copy this, paste it right here, and let's time shift it to the first frame using the f-start. And then we use the remesh node to generate a higher resolution of the shield, and the target size should be 0.005. I missed a 0 here. Okay, so the reason why I use the time shift here is that if we plug the object merge straight into the remesh, the PT num will be alter every frame, and we don't really want that. We want to freeze this shield in one frame, and then use the remesh, and then attach that to the original mesh using the point default. Okay, the first input should be the remesh, the second input should be the time shift, and the third one would be the shield. Okay, and now we can add a normal sort to compute our normal, and then we transfer the normal from the mesh to the particles. And in this case, we only need normal, so we untick this primitive tab, and then okay, let's plug into the wrangle. So it's still the same as the previous one. So let's create a pick node, and we use a distance of 0.003. Okay, so as you can see, the mesh is pushed further away from the shield by 0.03 distance, as you can see. Okay, so I'm gonna do the same thing with the to the shot, and I'm gonna put a time lapse to this so you guys won't get bored. Okay, so I have just finished the line match of the shield and the sword, and what we have to do right now is to cast this to this, because these nodes uh, are really expensive computation, so it's really worth to cast this to this. So I will name this to catch sword line match. And the same thing with the shield. I catch, change the name to shield. Okay, you can create a fast node for this, but I will cast this manually, and I will see you when I cast all of these files. Done. Okay, so I have already cast the line mask for the sword and the shield, as you can see here, and we are gonna create an actual light by getting outside and dropping down a light, and by default it should the light type is point, but we want the geometry light, and it expects us to have a geometry object. So let's create a geometry container for our line mask, and we're gonna name this to Lightmesh. Get inside, and for this we need to copy these two nodes to this container, and let's create an object merge. And for the object one, we need our sword, and for the object two, we need our shield. We can click this icon to create another object. Okay, so this is our light mask. We can turn off the preview in the viewport, so we can see the mask clearly. Okay, so let's create a color for this, and I wanna set it to an orange and yellow color. Okay, so let's create a node here, and we're gonna name this to audio light. Okay, so let's copy this, and for the light here, I'm gonna name this to mask light. Okay, in the area light options, we paste the node to the geometry object, and for the attenuation options, we need to click on active radius and use attenuation ramp multiplier. I think we need to delete this key, and copy the active radius to the ramp and distance, and set it to 1. Okay, so I think it's pretty much done, and let's get in the render view and hit render to see the difference, and we might need to add a snapshot to see the difference. Okay, so it's not really a huge difference, so we might need to increase the exposure of the light mask. Oh, we haven't identified the we haven't added the light mask into the matcha node. So for the objects, the candidate light, we need to add the mask light and the environment light. As you can see here, the light is successfully added to the character, and same for the ground. We need to add the mask light, and to furthermore control the environment light and the mask light in COM, we might need to separate these two lights into two passes, so we can control them individually. And so to do that, we need to hit the image tab, the extra image planes, and we need to add an extra image plane, and the vex variable, it should be combine lighting per light. And right away, if you click on this taskbar, and you can see the environment light and the mesh light are separated. And if you click on the environment light, oh, you can't see anything. So why is that? So let me have a look. Okay, so after checking for a while, I understand why we don't have anything in the environment line and the mesh line. So the answer is the render engine. We need to change the ray tracing to the physically based rendering. So we will have it. So let's see. Okay, as you can see, these lines are separated successfully. And we might need to click on untick the cell shadow on the mesh line also. And to increase the quality of this, I will increase the sampling quality to 3 to have a much smoother result. Okay, and same for the ground. We need physically based rendering, and let's have a look at the ground. Okay, so let's see. I forgot to add extra image planes, and same for the character. We need to plus this, and the vex variable, we need to add combine lighting per light. Okay, so this is the environment line and this is the mesh line. And you know the mesh line doesn't affect it, the ground too much, so it doesn't show anything. And last but not least, we need to change our camera resolution to 1080p so we can have our full HD render. And for the mancha chart and for the mancha ground, we need to delete this and set it to 101. Okay, so let's plug all of these mancha nodes together, and let's render all of them at once. And I'm gonna render all of these four nodes, and I will come with you together in Nook, and I will see you when I finish the rendering. Okay, so welcome back guys. So we are gonna come all of these elements together in Nook, and first thing first, you need to install the Asus color space. And if you don't have the Asus configuration, your result will be drastically different from mine. So just make sure to install it. And let's lay all of these together and do a slap comp. And I'm gonna create a checkerboard to play as our background. And if you can notice here, is the size format is 2K, so we might need to change the size format from 2K to 1080p, so it will match the render size. Okay, so for the checkerboard, we might need to delete the zero line here because it's kinda annoying. And let's reduce the center line width to 0 so the line will be disappear. Okay, so let's create a merge node by pressing M on the keyboard and plug the B input to the checkerboard and the A input to the ground. And if you recall in the Houdini lesson, we have already rendered this ground beauty by separating this beauty into two passes, the environment light and the zero light, and let's split them into two passes using the shuffle node. So let's create a shuffle, and for this shuffle I will split the environment line, and the other shuffle is for the zero light. So let me see. Okay, zero light and zero light. This is the environment light. Okay, so for this zero light, as I told you before, the zero light doesn't affect the ground too much, so it doesn't display anything here. But it's still worth to separate it out into two passes, and let's merge them back together. And the operation should be plus. Okay, so we have a identical result from our beauty, and let's also create a copy node to copy the alpha from this beauty to this plus, because currently we don't have any alpha when separating the shuffle. So let's create a copy by pressing K on the keyboard, and plug the B input to the merge, and the A input to the ground, and I might need to create some dots so to organize the scene a bit. Okay, so we have an alpha now, and now if you plug this merge into the copy, we have the same, we have the identical result. Okay, so for this shuffle, I might need to get it up so it makes the ground become brighter to match the scene. Okay, so let's do the same thing to the character, and let's copy all of this node and paste it here, and let's take the character here, plug all of this node to the character, and create a merge node, and the operation is still over. Alright, so we have a character that stay on the ground, and I think I will adjust this node later, because for now we just need to do a slab comp which merge all of these elements together, and I think I will do the main thing right now, which is do the combing on the effect. Okay, so let's create a merge node to add the effect on top of the shield, but the operation for this node is plus. Okay, so the theory of combing the effect is that you should have a flat layer of effect, and then you add a highlight layer combined with some glows, and I will explain that later. And for now, if you can notice about this render, there are still a lot of noises even though we increase the pixel sample to 8 by 8, and to make the particles have more finer details, we should add a node which is called RSMB, and this node is stand for Real Smart Smooth Blur. And just so you know, this is a paid node, but I can recommend enough about this node because it's really powerful for comping effect. And just right away, if I press 2 on the keyboard to this node, we can see a lot of difference. Right away we'll already get rid of a lot of these noises, and the particle is much more smoother, which is really nice. And for this setting, I managed to increase the blur amount to maybe this one, and I will decrease the sensitivity to about 25 is should be okay. Okay, so as I told you before, we will need a flat layer. Sorry, a flat layer of effect. So let's create a grid node, and to make a flat layer, we need to increase the gamma to about 1.32, and the gain I will decrease this a bit. Okay, so this is a flat layer compared to this one. We can see we have a lot of information right now, and I'm gonna create another grid node, and this grid node is just for color. So I want a yellowish color, so let's do it. Okay, and for this one, it's really up to you. You can choose a red shield or a blue shield, but I prefer the yellow. Let's create a grid node, and in contrast to this grid, which is the flat version, we will need to gamma it down significantly, and gain this and multiply this to have a to define the highlight layer of this effect. And if we merge this back on top of the flat layer, we can see a huge difference. So the operation should be plus, and if we view on this, it will create a kind of energy that flow on the effect. Okay, so right away, if you take this a input to the plus, we can see it. Okay, alright, so I'm gonna do an extra layer of this effect, and it's pretty much the same with this setup, but it will have a glow on top of it. So let's create a color correct node and plug this onto the RSMB. And the color correct node is kind of the same with the gray node, but it has a lot of options, and especially the saturation and the contrast. And let's increase the contrast of this. Okay, and gamma it up and get it up also. Okay, so let's use a gray node and decrease the white point, and for this one I will decrease the gain significantly and gamma it down also. And for right now we don't see anything, but if we add a glow on top of this, it will stand out. So I'm gonna use the expo glow, and this node is created by Rebelway, but you guys can use whatever glow that you like, and you can download the plugin from Nookiepedia, and they are completely free. So let's take a look on this. So uh, let's see, and I will increase the explosion to 7, and decrease the white point to 0.3, and increase again to this value. Okay, so we can see this glow. So let's create a flat version of it and create a dot here to make it organized. And for this one, I don't think I will just need to decrease the multiply. And then we can use a merge node to add this highlight layer on top of this flat layer. Okay, so let's create a gray node to define our color. Oh, actually we already set a color here, so let's just copy this gray node and paste this to here. So this is our glow layer, and we need to plus this on top of the previous layer using the plus function. Okay, so let's check the result by plugging the A input to the merge. Okay, so this is our seal effect, and it looks way cooler compared to the original render, as you can see. Okay, so for the sword effect, we can use the same setup here, and let's just copy it and paste this here. Plug the input of RSMB to the sword, and let's just check the result. And right away, the sword has already comp really nicely, and we need to plus this on top of everything. Okay, and finally I can add an overgrown glow on top of the sword and the shield, and to do that we will use the positive stamp. The positive stamp in loop is kind of the same with the object merge in Houdini, and let's just take the result of the the shield. We can hide our input, and create another one for the sword. Hide input, and for these two layers, we need to merge them together. And for the overgrown glow, we can use a node called AP glow, and let's plug this right into the merge, and let's decrease the intensity a bit to about 0.6, and increase the persistence, and add this back to the mainstream using the plus operation. Okay, and last but not least, let's create a grind node to finally render our sword. And let's click on file and navigate to where we save our render. Maybe we can name this to render dot with 3 hashes and exr. Okay, so the color space, we should alter this to output as RGB, and let's just simply hit the render. And that pretty much is pretty much how I did the slapcom for this shot. And I'm gonna leave all of the settings for you, so you guys can adjust the parameters on your own. And yeah, I'm looking forward to see your results. So if you have one, please comment down below your link to your results so I can have a look at it. And yeah, I think it's pretty much for this video. Thanks a lot for watching this tutorial, and if you have any questions, feel free to comment down below so I will answer all of them one by one. And if you like this video, please consider subscribing to my YouTube channel. And yeah, happy learning, and I will see you in the very next video. Bye.